Algebra 3, we are on the last section of review of this first unit of review. Going over things that we learned in Algebra 1 and Algebra 2, just getting it back in our head. Today is R.6. We're doing radicals and rational exponents all in one day. We're going to start with solving radicals. If it's a root and there's not a number in there, you know it's a square root. And the square root of 16 is 4. Okay, what times itself will give you 16. If you have a number and a variable, think about it this way. Break it apart into square root of 25 and the square root of x to the 4th. And if you can solve it, solve it. The square root of 25 can be solved. It is 5. And what I do is I just draw a line through it to remind myself that I don't need the root symbol on there, the radical symbol on there anymore if I solve it. The square root of x to the 4th, when we're solving variables, remember this is a square root, so our root is 2. And if you can divide that evenly, then you just divide it, and that's how you take the radical of a variable. So 4 divided by 2 is 2, which gives me x squared. So the square root of 25x to the 4th is 5x squared. Now, they're not always going to be perfect squares. 1 and 2 are perfect squares, but number 3 isn't. So the first thing I do is I take it apart, I look at the coefficient, and then I take apart the variable. And just for fun, I'm going to put the 2 in my root just to remind me that this is a square root. Okay, so if you don't see anything in the radical, you know it's a 2 and it's a square root. 80 is not a perfect square, so I need to separate that into a perfect square and something else. You need to look for the largest number that goes into 80 that is already a perfect square. And 16 goes into 80 evenly, so this is the square root of 16 times the square root of 5, because 16 times 5 is 80. So you can take that and you can break it apart into two things that multiply. The reason I split them into these two numbers is 16 is a perfect square. It's not going to do you any good to split it into 8 times 10, because 8 and 10 are not perfect squares. So you want to split it so it's a perfect square and something else. And then you're going to solve the perfect square. The square root of 16 we already said was 4. I can't solve the square root of 5, and there's not a perfect square that goes into that, so this is going to stay the square root of 5. We're going to do the same thing here. If you can't, oh, that's not 4, that's 5 up here. Okay? And remember, when we're taking the root of a variable, what we do is we take the root, the exponent divided by the root. 5 does not divide by 2 evenly. So I'm going to split this into something that can be divided by 2 evenly. What's the biggest number under 5, that's less than 5, that 2 goes into evenly? And that'll be 4. And so this gets split into x to the 4th and x to the 1st. The reason I have it split this way and not 2 and 3 is I want to take the biggest even number out of this so that I can divide it and solve it. 4 divided by 2 is 2, so this is going to solve to x squared. That's 4 divided by 2 is that 2. This one can't be solved or simplified, so this is the square root of x. My next step is to put it all together. Everything that was solved and came out from under the radical goes together, so that's the 4 and the x squared. Everything that could not be solved is under the radical, stays under the radical together, and so the 5 and the x stay under the radical like that. Okay, so that's the system we're going to use to simplify these before we try to combine them. 12 is not a perfect square. So I've got 3 times, I'm going to split the 12 into the square root of 4 and the square root of 3, because 4 is a perfect square. So I have the whole number 3. 4 can be solved. Square root of 4 is positive 2. Those are going to be multiplied. The 3 is going to have to stay under the radical. So this becomes 3 times 2. Now that this is outside the radical, we can multiply those as coefficients. 3 times 2 is 6. Square roots of 3. So that's the simplification of 3 square roots of 12 is 6 square roots of 3. We're going to do the same thing here. I've got 4 times, I need a perfect square that goes into 27, and 9 is a perfect square that goes into 27, so I'm going to split 27 into the square root of 9 times the square root of 3. And the reason I do that is I can solve the square root of 9. So I have 4 times 3. Once you solve it, it's not under the radical. This one did not get solved, so it stays under the radical. 4 times 3 is 12. So it's 12 square roots of 3. You can only add, think of the radicals as being like terms. They have to be exactly the same, kind of like variables. And if they are the same, you combine like terms, you keep the radical, and you add the numbers in front. So 6 and 12 is 18 square roots of 3. Okay, the next part of radicals that we want to talk about and review from Algebra 2 is when you have radicals in the basement. And what I always tell my students is you can't have rats in the basement. No radicals in the basement or in the denominator. So if you have a radical in the denominator, you've got to figure out how to get rid of it. The first thing I'm going to do is simplify that as far as I can. So, is there a perfect square that goes into 48? And 16 goes into 48 evenly. So I can solve the square root of 16. This becomes 4 square roots of 3. So now I've got 4 over 4 square roots of 3. I've got a 4 on the top and a 4 on the bottom. These are both whole numbers. They're not part of a parentheses. They're not under the radical. So I can simplify. 4 goes into 4 once. 4 goes into 4 once. So now I have 1 over the square root of 3, which is great. I've simplified it, but I still have a rat in the basement. There's no radicals in the basement. So what I've got to do is figure out how to get rid of that radical. And what I want to do is create something that's a perfect square, so that if I take the square root of the perfect square, the square root radical goes away. So what is a perfect square that 3 goes into evenly? Well, 9. 3 goes into 9 evenly, and 9 is a perfect square. What do I have to multiply by 3 to get 9? Another 3. But whatever I do on the bottom, I also have to do on the top. So what that gives me is 3 times 3 is 9, so I get the square root of 9 down here. 1 times the square root of 3 is the square root of 3. But now I can solve this only on the bottom, and I'm left with the square root of 3 over 3. No more radicals in the basement, so I've solved that. So the goal is to create a perfect whatever so that you don't have a radical in the basement. Okay, you want to create the perfect square. This, however, is a little bit different. When you have a radical that's being added to another number, in order to get rid of that, you need to multiply by what's called the conjugate. Does that ring a bell? And basically what you do is you have whatever these terms are, those are the terms in the new parentheses. Whatever this sign is, this is going to be the opposite. Kind of like creating a difference of squares. But whatever I do on the bottom, I also have to do on the top. And then what you have to be really careful of is the multiplication process. Okay, I am going to take this 3 and distribute it through the parentheses. When you multiply radicals, you multiply the coefficients. They can be multiplied together. Everything under the radical can be multiplied together, but you can't mix them up. So when I take 4 times the square root of 3, I can't multiply those together. Those are two different things, so they can't be combined. So it's 4 square roots of 3. However, square root of 3 times square root of 5, those are both under the radical. They got a negative out front, but I can multiply the stuff under the radical together, so that's the square root of 15. On the bottom, we're going to FOIL this, so you have to be really careful. 4 times 4 is 16, because those are whole numbers, so those can get multiplied. 4 times negative square root of 5 is negative 4 square roots of 5. I can't combine those because one's a radical and one's not. Then I take positive 5 times 4, that's going to be plus 4 square roots of 5. Again, can't multiply the numbers together because one's a radical and one's not. And then finally, I have a plus and a minus times a minus is a negative. These are both under the radical, so I can multiply under the radical. 5 times 5 is 25. I can't do anything here because these are different terms, and I can't simplify those because there's not a perfect square that goes into the square root of 3 or 15. So I'm just going to leave 4 square roots of 3 minus the square root of 15. But let's work on simplifying our denominator a little bit. We've got 16, I got that. I have minus 4 square roots of 5 plus 4 square roots of 5. So they cancel each other out because they're opposites. And then I have minus, this is the square root of 25. Square root of 25 I can simplify is simply 5. And now I can subtract those. So I have 4 square roots of 3 minus the square root of 15. 16 minus 5 is 11. And I no longer have a radical in the basement. Okay? If you have just a radical, you want to create a perfect square or perfect cube or whatever in order to get the rad out of the basement so that you can solve it. If you have a conjugate, you've got to multiply by it. If you have this number, you have to multiply by its conjugate to get it out. Okay, so we did all this with square roots. Same concepts still work with cube roots. You just have to remember that you're working with cubes and not squares. So this one I'm going to split apart into the cube root of 27 and the cube root of x to the 9th. The cube root of 27, you can solve that. The cube root of 27 is 3. For your variable, remember if you take your exponent divided by your root, if it divides evenly, that is your root. 9 divided by 3 is 3, so this is x to the 3rd. And that's as far as you can go. Okay, so we're going to do the same concept here. These are not perfect cubes, so we're going to have to do some breaking apart. I've got the cube root of 48. I have the cube root times the cube root of x to the 12th times the cube root of y to the 14th. Okay, and I'm going to do each of them one at a time. I need a perfect cube that goes into 48 evenly, and 8 is a perfect cube, so I'm going to divide this into the cube root of 8, and the cube root of 8 times 6 gives me 48. It doesn't do you any good to do 4 and 12 because 4 and 12 aren't perfect cubes. You want to find a perfect cube that goes into it. And then I'm going to solve that perfect cube. That's why we pull out a perfect cube. Cube root of 8 is 2. So this is 2 times the cube root of 6. That's simplified that cube root of 48 as far as I can. Now on this one, if I can divide the exponent divided by the root evenly, I can totally solve it. In this case I can. 12 divided by 3 is 4. So that solves to x to the 4th, and there's no root left over. On this one, however, 14 cannot be divided by 3 evenly, so I do need to split this one. I need the cube root of y to the 12th, because 12 is the biggest number under 14 that can be divided by 3 evenly. But if I have the cube root of y to the 12th, this has to be the cube root of y to the 2nd, because 12 plus 2 is 14. You know, when you multiply variables, you add their exponents, so that's what's left. This one I can solve, because 12 divided by 3 is 4, so this is y to the 4th. This one I can't, so it stays under the radical. It's the cube root of y to the 2nd. Then for my final answer, everything that came out of the radical goes together out front, so I have 2, x to the 4th, y to the 4th. And then everything that stayed under the radical has to stay under the radical. So I have 6 y squared under a cube root. And that's your final answer. Okay, and then we're going to talk a little bit about rational exponents. I love rational because it's a really fancy word of saying fractions. Remember that when you have a fractional exponent, I call this the exponent, this is your root. And remember, the root is always on the bottom because roots, like if you have a tree, it's like the tree is your exponent, if this is your ground, and these are your roots. So the root goes under the dividing line of the fraction. So if you're not sure which is the root and which is the exponent, the root is always on the bottom. And when you solve them, solve the root first, and then do the exponent. So for this, my root is a cube root. I'm going to rewrite it as the cube root of 27 squared. Okay, that's the same thing. The root is the thing on the bottom. That's what's going to go in the root. The other thing is your exponent. Do the root first. The cube root of 27, if I solve that, is 3. And then I'm going to square it. And 3 squared is 9. Okay. Here, my root is 2. So this is the square root of 9/25 to the 3rd. I'm going to do the root first. So the square root of 9 is 3. The square root of 25 is 5. And that whole thing is being taken to the exponent of 3. 3 to the 3rd. 3 times 3 times 3. That's fine. Is 27. 5 times 5 times 5 is 125. Right, if we're taking a power to a power, remember that every single thing inside the parentheses is going to be raised to that power. So we're going to multiply 3 to the 1 times 3 is 3. So this is 3 to the third. 2 times 3 is 6. So this is x to the 6th. And if I take 4/3 times 3, that's like 3 over 1. That's 12 over 3, or 4. So this is going to become y to the 4th. 3 to the 3rd power is 27. So this is 27, x to the 6th, y to the 4th. Okay. I'm going to simplify the 10 inside the parentheses because of PEMDAS. I'm going to simplify everything I can in here first. As far as the coefficient goes, 2 goes into 10 5 times, 2 goes into 4 twice. So I have a 5 on top and a 2 on the bottom. If I subtract my exponents, I have 5/8 minus 1/2. Remember, in order to subtract fractions, you need a common denominator. They both go into 8 evenly, so the 8's not going to change. 2 goes into 8 4 times, so 4 times 1 is 4. 5/8 minus 4/8, you keep the denominator and subtract, is 1/8. So this becomes 5 over 2 times x to the 1/8. And all of this is being raised to the 3rd. Everything gets raised to that power. 1 times 3 is 3, so this is 5 to the 3rd. 1/8 times 3 is 3/8. And then 2 to the 3rd on the bottom. 5 to the 3rd is 125. X to the 3/8. On the bottom, 2 to the 3rd is 8. Okay, enjoy your homework assignment.